Hi, in this mini lecture we'll be drawing the timings for D-type latches and flip-flops. As you already know, the description of latches and flip-flops in terms of STE, state transition equation, state transition diagram, and state transition table are exactly the same. They don't depend on CK triggering condition. CK is not existent in the equation, in the diagram. It's always only represented by arrows and in the same form for latches and flip-flops. And state transition table doesn't contain CK at all. So, but latches and flip-flops operate quite differently, and to show these differences, the timings and the changes of the Q signal in time should be presented on these timings. So we've got two types of latches and two types of flip-flops for each of the 1-bit memory elements. And latches. For latches, we've got let's start with flip-flops. They are simpler. So flip-flops are triggered on edges. So only at they can change its Q output at time instances or only. Okay, when there is a rising edge on the clock input or falling edge on clock input. So only time constants, yes, they can change its state, they state only them. And latches. Latches can change their states when there is a level, so in the period of times, not in the time instances, but within the periods for a longer time, they can change. They can operate according to this description. So they are allowed to operate within ranges of time. Let's start with point 1. Q1 will be the first timing. And what we should know before we start drawings is the initial state, initial content of the memory element for time equal to 0. Let's suppose it is 0. So we now know what to start with. Okay, we start with 0. And because it is triggered on the rising edge, we simply must stop at each rising edge of clock and decide what's the next value on the Q should be according to the STE, which for D-type is very simple. Q of t plus 1. The next state is simply D of t is what is present on D input. So we must know that when there is a triggering edge, we must look at the value of D, and this value will be the next value of Q. So now here you are 0, D 0, so no change on Q, 0. Now you've got 1 on D, so this value will be copied to the Q output. And similarly, no change because 1 is still present on input, and there is a change here because when the edge is occurring, D is equal to 0. So the value of D will be copied according to this equation. So in the first case, a rising edge triggered flip-flop, we've got the following timing. And the second is Q2 is a falling edge, so we must stop at, let's suppose the initial values will be the same for all the variants of D-type flip-flops and latches. We must now stop and decide what to draw at these points in time. So now you've got a 1 earlier than before, so the change will occur earlier, the change to 1. Here you've got 0. This change was not present in the previous case. Then 0 again, and then 0 again. So this is the second, quite different. Yeah? Third, let's take gray color. In this case, we'll be analyzing the periods when there is a clock equal to 1. It is in these periods of time, this element will operate in this manner by copying D on Q. Copying D, not at points in time, but within periods of time. So let's start with 0 as before. We must stop at the beginning of the periods, decide, as you can see at the beginning D is 0, and then only here, just here, it is changed to 1. So now I simply, starting from the beginning of this active period, within this period I simply copy the value of D. The D is changing here, and at the end of this period you maintain the last value and go further to the next period of time where you do the same, for which you do the same. You copy the value of this. So as you can see, I'd like to, this value which is copied when there is activity, activity period for this latch, and that is active on within this logic level periods of time. And the same is true for the next one. It simply starts here and finishes here. The next one is here, and the next one is here, and the last one is here. And these periods will be copied on the outputs, on the output. So, and in between, nothing will change. In between, nothing. Now we start this period, so we must copy D, and D is at the beginning is 1, and then it is 0. And the period ends. You must maintain the last value until the next active period, which is here, and you now copy D. It is a copy of D. So let's show these values. It is a copy of D, and also this is a copy of D. Okay, great. Yellow periods within the yellow periods of activity. Alright, so now the last case is to draw the Q4 when there is active low latch. These are periods when it is active low periods, and within these periods Q must be equal to D. We start as before with 0. At the end of this period, D is also until the end. So yes, and now nothing should change until the next period of activity. And now, as you can see, there is 1 on D, and that's why this value of D will be copied and will not change until the next period of activity. And you've got, as you can see, 0 on D, so 0 must be on the output. And then in the middle, around middle of this period, you must return to 1 and maintain to the end of this period. You enter the next period of activity by changing to 0, because you have 0 within this period. You don't change anything until the next period of time of activity. And as you can see, 0 is present on the D, so 0 will be until the end of this. And as usual, you can see the value of D here when there is green color. Yes, green periods are activity for the for case. So you've got this one with this period, and you've got D with this, and you've got D value with this period, and D value at the end, to the end. Okay, and as you can see, these are the same values of D. Thank you.